Alright y'all, so this is going to be kind of like the final video before spring break. Just kind of wanted to go through just a little bit of everything in Unit 3 and kind of go over what you need to know for the test. First of all, I'm just going to go through some of these. If you want to skip around, look in the description. There's time marks for you know, each. If you want to, like, say you're like, I don't want to learn how to factor, I remember how to do that, I want to look at parts of a quadratic, I'll have the links in the description that kind of go through all the timestamps, so you can skip around and look for what you want. Anyway, so in this video I'm going to go through these 5 things and making sure that you know how to factor, specifically with trinomials, because that's the ones we've been dealing with the most. Making sure you know how to convert between standard, vertex, and intercept form, and making sure you can identify all the parts within those forms, you know, like what your A, your H, your K is, and things like that. 3, I'll talk about the parts of a quadratic and their definitions, so like, you know, vertex, axis of symmetry, things like that, your A value, your C value, H and K again. All this kind of intertwines, but I'm just kind of re-emphasizing some things. In the 4th section, I'll talk about word problems, because we haven't done a little bit of that. We did one worksheet on that, didn't really do a lot. And lastly, number 5, I'll talk about how to go from a graph to a function. Not going to stress out number 5 a lot, but kind of want to go over it because that's what I'm going to be going over tomorrow. Anyway, let's start off with number 1, factoring. Again, if you want to skip through this, by all means, look at the time codes in the description, and you can skip forward. Let's just start off with some basic factoring, okay? Now, these are going to be the ones you're going to see most of all. Trinomials, right? Trinomial because there's 3 terms going on, okay? So first of all, when I see a negative in front, I always tell you guys to pull it out, to factor it out. When I factor it out, I'll end up pretty much all I do is I put a negative out front, I switch all the signs. So every negative becomes a positive, every positive turns into a negative, okay? So that's really all it does, is it switches the signs. Alright, now let's actually factor this thing, okay? So, first of all, for these, you always say to yourself, what multiplies to get you the back? It also adds to give me that middle. Now, when I've seen most people do this, all right, what's right there? Well, if there's no number, no coefficient in front of the x, there's always kind of like a 1 there, right? So you're trying to think of what multiplies to get you -2, but adds to get you a +1. And again, off to the side, I like to list out my numbers that multiply to get me -2. First of all, you really only have 2 options here. 2 and -1, and -2 and a +1, right? Those are our 2 options. Now, which of those can somehow add in some way to get me +1? If I 2 plus a -1, or 2 minus 1, that gives me a +1, right? So this is going to be the one I'm going to choose. Again, if you're having trouble, look back in my videos and try to find something more specific. Like if you're still having trouble with factoring, by all means, just look through it, okay? So this will end up being, we have to write this off to the side right here. Y equals, don't forget your negative out front. Now we said a +2, right? So we have x plus 2 in one set of parentheses, and then in the other set we're going to have, well, you said -1, so x minus 1. That's how we're going to factor these. Now, this is really important whenever you have to find the x-intercepts, right? Because you have to factor and then set each set of parentheses equal to 0. But I'm just kind of stressing out how to factor for now, okay? And also, this is how you convert from standard form to intercept form, okay? A lot of this stuff is intertwined. A lot of this stuff kind of just repeats itself and overlaps. So that's kind of the hard part about this unit. Everything kind of overlaps. Anyway, let's look at the second example I have right here. 2x squared plus 8x plus 8. First of all, your first step when you're factoring, didn't really do it in this one because there wasn't anything really to pull out of everything except a negative. On this one right here, they're all even numbers, 2, 8, and 8. So obviously I can pull a 2 out of everything. Let's do that. Meaning, it's like I'm dividing everything by a 2. I pull a 2 out of everything, right? So now we're going to do the same thing we did there. What multiplies to get me 4, that also adds to get me 4, okay? Well, we only have one option really there. Hopefully you can see 2 and 2 multiply to get me 4, but also add to get me that middle 4 right there, right? So, my final factored form of this would be x, sorry, I missed something. What did I miss? I missed the 2 out front, right? Never forget that 2, wherever it was, you know, you factored it out at the beginning, so you can't just leave it. 2x plus 2 and another x plus 2, okay? Again, this would be basically converting from standard to intercept form, but I'm just making sure you know that you better be able to factor on this test, okay? Last but certainly not least, this is one of the harder ones I could give you, and one of the ones that I think is important to know how to do. First of all, you see a negative out front, so what did I tell you to do in the first example? Pull it out. Let's do that. Pull out a negative, so that means all that does is switch all the signs. So that negative 2x squared becomes a positive 2x squared. Positive 3 turns into a negative 3x, and then positive 14 turns into a negative 14. Alright? Now, The problem with this is I have a 2 out front, and besides, I mean, if you think of any numbers that multiply to get you 14 and add to get you, or sorry, multiply to get you negative 14, but add to get you negative 3, nothing's going to work, right? So for this one, you're going to have to do one of 2 ways: either guess and check, you know, where you have to do all that distributing and, you know, checking your answer and stuff, or star, whichever one you want to do. I'll do both. Again, I'm going to do both just to emphasize, all right? So let's do guess and check first. I'm going to do that first. So I'm going to try to find some numbers that multiply to get me 14 and 2 and 1. Let's see, 14, I got a couple options there. I either got, let's see, -7 and a +2, negative 2 and a +7, a +14 and -1, and a -14 and a +1. All these are our options for -14. Those are our options for 2. So now we have to choose. What do we want to do? Well, let's just say I'm going to actually choose the correct one so you can see what it will end up looking like. So first of all, don't forget your negative out front. Always going to have 2 sets of parentheses when we factor something, right? So in one set, let's just say I chose, you know, obviously whatever goes out front, 2x and 1x. Now, I have to choose what's going to go out back. I'll go ahead and tell you, it was this first one right here, -7 and +2. Okay, and this is the order it goes in. Now, if you chose another one, if you chose, let's say, -2 and +7, you're gonna have, you distribute, and then you combine like terms, and then you say, wait a minute, I didn't get back to what I started originally. I didn't get the original thing back. So you're gonna have to basically say, all right, try again, try another combination. Okay, but again, this is the working combination. I'll show you why it works. Because if I distribute this thing out, I'll end up getting y equals, don't forget your negative out front, and then I distribute all this out, I would end up getting 2x squared plus 4x, then let's distribute this bottom, minus 7x minus 14, okay? And then I combine like terms right here and right here. So drop down the 2x squared, 4 minus 7 is -3. X, that is, minus 14. And if you look back, this is the exact same thing that we had up here. And we know if we distribute that negative, and we're going to get the same thing as we had before. So we know we chose the right combo, and this would be our factored form of this answer. Now, if you don't like guess and check, we can do start. I'm going to do that right now, all right? So if you do start, I'm going to kind of write off this like it's getting kind of messy here. If you do start, I'm going to go ahead and rewrite my equation right here after I factor out the negative, that is. And let's label our A, B, and C. A, B, C. Alright, way you do star. Make your star, first of all, obviously. Up top's A times C. On the bottom is my B. Okay? I'm going to try to make this a little bit more easier for you to see. There we go. What's A? Well, my A is a 2. My C is a negative 14. 2 times negative 14 is negative 28, right? You can always use your calculator on this test. I'm not going to, forbid you from doing it. And then from there, I'd look at my B. My B is a -3. And remember, what goes off on the sides is whatever my A is with whatever variable I'm dealing with. So 2 on both sides, and also your X is going to go on both sides. Now, comes the part where you got to think a little bit harder. You're trying to find some numbers that multiply to get you just negative 28, but also add to get you that -3. Go and tell you. If you want to write that off the side, write all your multiples of negative 28. Remember, in the calculator, you can pull that up by going into your y equals screen and typing in negative 28 over x and looking at your table, okay? Which I think I may show y'all tomorrow to kind of refresh your memory on that. But if I did that, I would end up finding out that -7 and +4 are the two numbers that multiply to get me 28, negative 28 that is, but also add to give me -3. Now, your answer isn't 2x minus 7, 2x plus 4. Now, 2x minus 7 is one set of parentheses, which we got over here. I know you can't see it, but we did get that over there, all right? But what you have to do now is you have to think about, well, I've got to kind of think of it like reducing a fraction, okay? 2 fourths can simplify down to what? Well, that can simplify down to 1/2. And don't forget your x stays where she was. Now, this is my final answer. Now, the way you write this is 2x minus 7 in one set, and then 1x plus 2, or just x plus 2. You don't have to put the 1 in front of the x if you don't want to. Now, the one thing you're forgetting is if you chose this as your final answer, you would be wrong, because you forgot at the very beginning, what did you have out front? You still had that negative out front. So I do have to include that negative that was out front all along. This is going to be one of the harder ones, and there is going to be one like this on your test. So just, just a fair warning, okay? Okay, that was part 1 of factoring, all right? Let's make sure we understand the different types of quadratics and the way they come in, the shapes and the sizes they come in, okay? First of all, standard form is the one we've been dealing with probably the most, is the one we started with. Let's go over what she looks like. Ax squared plus bx plus c. Okay? Find a lot of stuff with standard form, okay? Let's review what vertex is. A x minus h squared plus k. Alright, and lastly, intercept form. Really, there's no easy way to write this. I've seen some people write like this: a, x minus p, x minus q. I'm going to go through these just real quick to remind you of what each of the things are. A, what does that tell you in every single equation? It exists in all of them. Well, that tells you whether or not it's going to open up or open down, okay? If it's positive, it's concave up. What if it's negative? It's going to be concave down, right? And then also, if it's concave down, what do you have? You have a max, right? And if it's concave up, you have a min. And we've been doing that every day pretty much. I've been saying that over and over and over again, so hopefully you have that by now. Okay, now the other thing I'm going to talk about real quick is I think we kind of know how to use, you know, our A, B, and C for this, but on these other ones, on the vertex form and the intercept form, we still seem to have a little bit of difficulty when we're trying to figure out what's what and what means, what letters mean what, okay? First of all, your C is always your y-intercept, okay? In standard form, okay? In standard form, it is your y-intercept, okay? And then remember, how do you find vertex? Negative b over 2a. We're going to do that in just a second, okay? Now, let's look at vertex form for a second. Really, that's the only two things you really need to make sure you know with standard. Knowing how to do all the stuff we did at the beginning, plus knowing the fact that, A is in every single equation, okay? For vertex form, however, I do want to make sure we're clear on something. Your H is always going to be your x value of your vertex, and your k is always your y value of the vertex, okay? So for example, I'm going to just write below this to make sure you know, and I'm actually going to go both ways. I'm going to give you one, I'm going to ask you to identify the vertex, okay? Let's say you had something like this. Something like this, and I said, find the vertex of this thing. First of all, if you remember what it was that's a negative sign in there, so you always got to think of, I'm going to switch the sign of whatever's inside, okay? And that's going to tell me what my x value, my vertex is. So my vertex for this thing would be, well, switch the sign of that, so negative 3 would be your x value, and your y value is just whatever the number is out back, so minus 5. That's my vertex. That's my vertex of the graph, okay? Now, if I told you to go backwards, I think we're still having trouble, like, knowing how to go backwards sometimes. So let's say I give you a vertex, okay? Let's say I give you a vertex of, I don't know, 4, 0, 4, 0, something like that, okay? Let's say I give you this vertex, and I want you to write it in vertex form. I want you to write a possible formula, possible equation in vertex form for what it could be. Well, if you remember, our H it's gonna go inside, okay? But remember what I did with this one, that was a positive 3 inside, but I switched it to a negative 3. The same rule is gonna apply. And by the way, real quick, the only other thing that I really didn't stress about was the fact that you don't really know what your A is. There's really no way to tell. Just by giving these 2 points, you have no idea. So I usually just leave an A out there just to kind of say, hey, it could be a 1, it could be a negative 5, it could be 1,000,000,002. For all I know. Doesn't really matter as long as I get whatever's right inside for your H and your K, okay? Well, anyway, so before I said, I had a positive 3 inside, I switched the sign to a negative. So we're going to do the same thing but backwards. So instead of being a positive 4, it's going to be a negative 4 inside, okay? That's what's going to go in for my H, all right? Now my K, you can put plus 0, but realistically, I don't even need that plus 0, do I? I can literally just cover this up and I can say, hey, this is my equation right here. You can have it if it helps you, but you don't need it. In fact, I would prefer this way because, hey, I mean, you don't need that K out there. You know it's not out there, so it's going to be a 0, right? Okay, that's vertex form. Again, I'm kind of going quick, so just make sure you look back at any other videos I have on that, all right? All right, lastly, let's do intercept form. Again, this one, to get this thing, get your x minus and your x minus p, x minus q. The letters don't really mean anything. All this is knowing the fact that you need to factor to get an intercept form. That's actually the other name for this form is factored form. Intercept form, factored form means the same thing. So let's say I gave you, again, like I said, something like, I don't know, I'm going to do the same kind of deal with as I did with vertex form. So let's say I gave you something y equals 2, say negative 2, why not? Doesn't really change anything, but let's do it. X plus 1, x minus 10. Okay, and I told you to find the x-intercepts of that. Okay, what would you do? Well, you'd set each set of parentheses equal to 0. So I would just do that. X plus 1 equals 0, x minus 10 equals 0, and solve from there. Well, easy as pie. One of my x-intercepts is -1. The other x-intercept would be a positive 10, right? Hopefully that makes sense. And now, the other way I really didn't show you how to write it. I just kind of wrote x equals x equals. Sometimes people write it as points, so they may write this as -1 comma 0 and 10 comma 0. Just know these things are the same thing. That's why they're called your zeros. They're when y, your y coordinate, is indeed 0, okay? Now let's work backwards, because I still think I didn't really stress about this too much, but let's work backwards, okay? Let's say I have something, I don't know, my x-intercepts are, let me think. X equals 5 and x equals 0, okay? Well, if you notice, really all that happened right here was I mean, when I solved this thing, that positive one turned into a negative one, kind of like when I was fiddling with my vertex, right? So the same kind of thing's going to happen here with this x, from converting like to an x-intercept, given an x-intercept to a function. It's going to work the same kind of way. And I'm going to put my a up here just to kind of have it. And in there I'm going to put, well, I'm just going to switch the sign, x minus 5. And you can put x minus 0 if you want to, or I can literally just put y equals x minus 5 and then just an x, okay? And if you want to flip that around, you can by all means flip that around. I'm not going to stress on this too much. Just knowing the fact that you can actually write it, especially in this form right here, literally just switching the signs is all I'm going to make you really do, per se, okay? In Math 3, you're going to stress more about going from here to there, okay? For now, I'm not going to, though, okay? I know this one was actually a bit of a difficult one for me to get through, and I think we still may need to work on this a little bit more, okay? Anyway, let's kind of recap all the different definitions. This is part 3 we're on right now. I'm going to recap all the different definitions of kind of all the words we've been going through, okay? It's a lot of them. Vertex, well, how do we find vertex? Well, negative b over 2a, right? And I'm going to write, I messed up right there, x equals negative b over 2a, right? That gives me my x value in my vertex. How do I get my y value? I get the y value by plugging in, okay? By plugging that x, whatever I get for this number, into my original equation, and that's going to give me my y value, and I'm going to have two numbers, an x value and a y value. That's going to be my point, okay? Now, vertex, we didn't really, I don't know if we've stressed about the definition, like the wording of like what a vertex is, but really, I mean, all the time, your vertex has always been a max or a min. It's always going to be a max or min, okay? And also, what it's also going to be, I mean, it's also going to be considered a turning point of a graph. Okay, and you can see that. I think when I did that boomerang problem, if you graphed it in the calculator, you saw that that's when that boomerang actually turned around, okay? So that's kind of what a vertex is. It's also considered a max or min, as well as a turning point. Now, at AOS, what does that stand for? Axis, of symmetry, right? So what that is really just the same x value, right, as my vertex. But what is an axis of symmetry anyway? Well, remember when we talked about symmetry, it's where you can cut something in a particular way so that one side looks like the other. That's really all it is. It's a way to cut your graph in half, okay? Now, I'm thinking of a technical definition for it. Line where both halves of quadratic are equal. And again, I think you guys know that, but I'm just saying, like, on the test, there's going to be a little section where I ask you to say, hey, can you match this term right here with this proper definition, okay? And as long as you kind of know the gist of what axis of symmetry is, you're going to be good. Now, concave up or concave down. Well, we all know what a concave up looks like. It looks like this. It's a U shape, right? And therefore, if it's concave up, you're going to have a minimum. Well, how about concave down? Just the opposite. You're going to have a maximum, right? A min if it's concave up, a max if it's concave down. Now, what determines if it's going to be a minimum or maximum? What letter? If you remember, what letter was present in every single one of my equations? Well, A was present in every single one of my equations, okay? In standard form, in vertex form, as well as in intercept form. Every type of form has that A in it, right there and there and there. Well, if your A is positive, and I said this before, but I'll make sure I say A is positive, concave up, right? If your A is negative, concave down. Easy enough, right? That determines your concavity right there, all right? All right, let's keep on going. I'm just kind of going through basic definitions. Pause if you need to, by all means. All right, last couple, just going to kind of recap on how you find it and just kind of how it works, okay? Max min, well, we kind of already said it. It's going to be the highest point or lowest point of the graph, right? Easy as pie. Now, this is going to make sure, hopefully, that you pay enough attention to the point where you can tell max is the highest point and min is the lowest point. Because when we get to the word problems, that's going to be where it's going to get a little trickier, okay? Now, a max or min is also, remember what I said, the vertex is your max or min? Well, your max or min is also going to be your vertex. So you can always find a maximum or a minimum by just literally doing, you know, x equals negative b over 2a and going from there, okay? That's really it. I had nothing else to say about that. X-intercept, how do I find the x-intercepts? Well, if it's not already factored for you, you have to factor, right? I have to factor to find the x-intercepts, okay? So star method or guess and check or something like that. Now the x-intercept part, or sorry, the actual part where you have to, what am I thinking of? Where you actually have to understand what x-intercept is when it crosses, when your line, your equation crosses the x-axis, okay? Now moving on nicely into my y-intercept, it's going to be when it crosses the y-axis, okay? Remember, y-axis is the one that's going up and down. Your x-axis is the one that's going left and right, okay? Now, how do I find the y-intercept? Well, if it's in standard form, it's always my c value, okay? It's always my c value in standard form. Now, if it isn't in standard form, you have to do just some distributing, something like that to kind of get it in standard form so you can then look at your c value. But really, most of the ones we're going to look at, if I'm asking you to find the y-intercept, it's already in standard form. All you got to do is look at the c value, which remember is also your last number in your line, right? So if I have something in standard form like this, it's always my last number right there. That's always my y-intercept right there, okay? Okay, so we've gotten through 1, 2, and 3. Let's go on to number 4, which is kind of addressing some word problem-y kind of stuff, okay? Write this one down for me if you could. So I'm going to kind of try to pan this nicely so you can actually hopefully see it. There we go. So Ali glides off a ramp on a skateboard with a path modeled by the following quadratic. F of x, or you know, that's the same thing as y, right? Equals negative x squared plus 9x plus 10. Find his max height when he hits the ground and the height of the ramp, given that, you know, x and f of x are in feet, okay? I'll give you, pause this video if you need to write this down, but let's go ahead and think about what we're gonna do. Max height, what is that? That's the maximum. Which, if you remember what I said a minute ago, is also gonna be your vertex. So we can find the maximum without doing all that crappy graphing we had to do and doing it in the calculator that a lot of us hated, okay? So we know what we need to do for this first part. Second part, hits the ground. When it hits the ground, okay? Well, let's actually graph it to see what it looks like. Now I'm going to just sketch it off to the side right here, just so I can see what it looks like. If I sketch it, this is going to be what it'll end up looking like. Okay? Now, if I'm asking you for when it hits the ground, first of all, let's say this is the ground, okay? Now, this part is in the negative, isn't on the negative side of the x-axis. So, I mean, and his actual path, when he launches off the ramp, he will be right here, okay? I mean, think of that like that's, I mean, you wouldn't launch off of a ramp at this height. You would just go across the whole, across the x-axis, okay? So this is your actual ramp, your launching point. Now, whenever he hits the ground, what's that called? That's called an x-intercept. That's when he hits the ground. Now we know to find the x-intercepts, we have to factor, right? So there's, boom, we know how to do the second part. Factor to get my x-intercepts. That's what we got to do. Now, again, like I said, remember, we're not going to necessarily look at both x-intercepts. We're only going to look at one of them because really, I mean, if you think about my path, and I believe on the test there's one like this, and just make sure you pay attention to the fact that wherever it hits the ground, I mean, obviously, you're going to be going forward. You're not going to be going backwards off a ramp. You're going to be going up and across. You know, when you go off a ramp, you're going to be launching upwards and across, right? So you need to find one of these x-intercepts, not both of them, just one of them. Again, we've done things like this in some word problems, but I wanted to make sure I go over one more time, okay? Lastly, it says the height of the ramp. Now, this is going to be a bit of a trickier one to deduce, and I kind of gave it away a minute ago, but this will be your whatever your y-intercept is, which remember is your c value. So I actually already know how high it is off the ground, okay? The reason why is, I mean, like I said, is kind of one of those things where it's a bit common sense, and it's going to, hopefully this will get better with you at time as you kind of get through more math classes and get used to this a little bit more. It's just looking at my graph here. Like I said, this is kind of like how high he starts off. He's going to go higher than that because, I mean, he's going off a flipping ramp, right? He's going to go higher than that. So a lot of times what they will say is, and sometimes I'll give it to you, I'll say, they'll find the starting point of the ramp, and I will just say it's the y-intercept. But know the fact that, and I think you guys have done this in Math 1, at least I'm doing that in my Math 1s, when I say where something starts, it's always the y-intercept, okay? And again, we find that by finding the c value. And if you want to do some more examples of this, by all means, I can make some more videos on this before the test. Anyway, let's go ahead and find all these. Max height, maximum, or vertex. When he hits the ground, x-intercept, so therefore we have to factor. And lastly, the height of the ramp. The y-intercept, the c value. All right, let's do the first thing, maximum vertex, okay? Well, how do we find vertex? Negative b over 2a, right? So let's do that. So max height, let's do it. Gonna find the vertex. How do we do that? Negative b over 2a, right? Let's do it. All right, negative b over 2a. What was our b? Let's look back, and actually I can just go ahead and write it down right here. I don't know why I'm flipping back and forth. Negative x squared plus 9x plus 10, okay? Let's label our a, b, and c for me. A is going to be, wait, there's not a number out there. It's just a negative sign. Well, we can always assume it's a little -1, right? This is my b, and this is my c. Let's go ahead and figure out what this will end up being. We will get a fraction for this, okay? So my b is a 9, but that negative tells me I'm going to switch a sign, so not a positive 9 on top, but a -9 over 2 times, what's my a? A is a -1. All right, so this will end up just being 9/2. Or if you want to write it as a decimal, which I may just write as a decimal, 4.5. Now this is your x value of vertex, right? How do we find the y value? How do we find the y value? What do we do that? We plug it back in, right? We plug this thing back into our equation to find the y value, okay? So let's do that real quick. 4.5 squared plus 9 times 4.5 plus 10. Let me do a quick calculation. Alrighty then, just did the calculation. Got it to be 30.25. That's my y value of my vertex. Now, what this doesn't tell you, and what it doesn't really ask you, well, it tells you what the max height is. Now, first of all, when you think of height, do you think that's going to be the x, like, you know, in the x, or the y? Well, I mean, if you think of it, if I graph, you know, like if you look at my equation that I graphed right here, this is my x-axis, right? This is my x-axis right here. This kind of tells you how far he's going, really. But this right here is my y-axis. That'll tell you how high he's going, okay? So just know the fact that if they ask you for how high he goes, they're not asking for the x and y value of the vertex. They're just asking for the y value. So how high he went? Well, he went 30.25. Now what unit are we in? Feet, yards, miles, what? Well, feet. He went 30 feet in the air. That is his maximum height that he goes, which again we found using the vertex. Again, a lot of this just takes some time just to kind of get used to that. Again, there's not really going to be very many problems like that on the test, just 1 or 2. I just kind of want to make sure we're aware that, hey, max height is just the maximum, okay? Now you can also do this in the calculator. Just know that by all means, you can find this in the calculator by doing, remember, second trace and all that fun stuff. But again, a lot of people, I was surprised about how many people actually prefer doing it by hand, which is fine. It doesn't really matter to me which way you do it. Both ways work. Just know the fact that if you have like trouble doing it like this and you're like, I don't quite get that, you can always go into calculator and do second trace, okay? All right, what was the next thing they told us to do? I believe it was to find the whenever he hit the ground, when he hit the ground, okay? And remember what I said before, when he hit the ground, that was finding the x-intercepts. How do I find the x-intercepts, you guys? Well, I have to what? F word do I have to? I have to factor, right? So let's go ahead and factor this thing. Let's remind ourselves what the original equation was. Y equals negative x squared plus 9x plus 10. Now, going back to what we did before, remember I said if you have a negative out front, what am I going to do? I'm going to pull her out. So, negative out front, all that does is change all of the signs. Okay, those are both minus signs right there. I don't know why I made them like that. So now what I'm going to do, the back number, ask myself what multiplies to give me 10, negative 10. But also adds get me negative 9. Now, I saw some people doing this by star method. You can do it by star method if you feel like much more comfortable. Star method works with any trinomial at all. So if you want to do everything with star, by all means do. But some people prefer to do this old-fashioned way. Anyway, so what's some numbers that multiply to get me 10? Well, negative 10, that is. You got 5 and negative 2, negative 5 and positive 2, 10 and negative 1, and negative 10 and positive 1, okay? Remember, you're trying to find a pair of these, one of these pairs, not two pairs, 4 pairs that is, that somehow adds in some way to get me a -9. 5 and minus 2 won't work. -2 plus 5 won't work. 10 minus 1 gives me a +9, but not a -9, so that's not going to work. The only option we have, and indeed the correct option, would be -10 and +1, okay? Let's go ahead and factor that. So, you said a -10, so we're going to have x minus 10 in one set. You said a +1 as well. X plus 1 in the other set of parentheses, okay? Now, how do we find the x-intercepts from this? We set each factor equal to 0, okay? And x plus 1 equals 0, right? So on one side, I'm going to have to kind of write this off to the side real quick, you guys. So we'll have, one of our x-intercepts will be a +10, and the other will be a -1. All right? Now the question asked is when Ali hits the ground, okay? Again, my suggestion is kind of look at your graph and think about how this would actually look in real life, okay? If someone launched off of a ramp, this is my ramp right here, okay? Someone launched off a ramp, first of all, where they would hit would be over here, right, on the positive side of the x-axis. They wouldn't hit over here. This is kind of where they started, you know, going up the ramp and then going over, right? This would be the x-intercept that I would want, not this one. So I want the positive x-intercept, okay? That's what I want. That's the one I want. I don't want the negative one. I don't care about that one. I want the positive one, okay? So which one was the positive x-intercept? Well, 10. What does that mean? That means he was 10 feet away from where he started. That's where he hit the ground. So Ali hit the ground 10 feet away. I guess you could say away from the ramp, all right? That's how far he hit the ground. That's how far away he actually had to go. He went before he hit the ground, okay? All right, last, so certainly not least, okay? The last question asked us, let's refresh our memory on what the question was. So far, we found the max height, which is the vertex, right? Again, you can do that calculator or you can do it by hand. We found when he hit the ground, which again was the x-intercepts, and by doing that, we had to factor. And lastly, let's find the height of the ramp. Remember what I said? That's going to be just your y-intercept, my c value, so my actual height of the ramp will literally just end up being this, 10 feet. Height of the ramp is 10 feet. Because remember, it's always your y-intercept is always your c value, which is whatever is out back, which is a +10. Therefore, the height of the ramp where he starts on his little flight is going to be 10 feet, okay? All right, that was a bit of a rough one. Again, there's not really going to be many like that on the test, but I want to go through one so you can at least get a feel for it. Again, a lot of this you can do in the calculator, and a good bit of it is common sense, but I did want to just go through it real quick, okay? Last thing I want to go over before I close the day, I know it's a bit of a long video, okay? Last thing I want to talk about is just making sure we can go from a graph to a function and vice versa, all right? There's not really going to be very, like I said, not much on this on the test regarding to this, but I do want to at least cover it, okay? So graphs to functions and vice versa. All right, so let's say I give you something like, I don't know, let's say I give you this graph. I'm going to sketch something really basic here. And I tell you that vertex is at 3, 5. That's where the vertex is at. That's my vertex, all right? That's V for vertex, okay? And I told you to find, like, say, write an equation for it in vertex form, okay? So find an equation of this in vertex form. Now, how would I do that? Well, let's remind ourselves what vertex form is, okay? This is vertex form. A, x minus h squared plus k, all right? Now, first of all, what do you notice about this? Is this thing concave up or concave down? Well, you can tell it's concave down, right? So therefore, what do you know about your a value? You know this is going to be, your a is going to be a negative, okay? You know that much. You don't know if it's going to be a -1, it's going to be a -2. You don't know if it's going to be -1,222. We just know a is going to be negative, okay? Now, let's remind ourselves what our h and our k is going to be. Our h is our x value of our vertex, so that's 3, and our k is the y value of the vertex. So all we're going to really do is plug this stuff in, okay? Y equals, I'm going to write this right over here. Again, we don't know much about our a, so we can just put, really just put like a negative a if we want to, so we know just, hey, it's going to be a negative, all right? X minus, what was my h? My h was a 3, squared, plus my k, which is just a 5, all right? Now, just to give you a heads up, what I would do on a test is I give you a bunch of options. This would be my answer choices right here, okay? Let's say you wrote this down on your paper saying, I think it's going to look a little something like this. this would be my answer choices right here. Let's just say I had 3 answer choices. This would be the ones I'd give you. X minus 3 squared plus 5, x plus 3 squared plus 5, and lastly, now notice none of these look exactly the same thing as what you had up here, okay? First of all, let's look at this first one. Well, the vertex adds up, right? Because if I found the vertex of that'd be positive 3 and positive 5. But what do you notice about what's in front? There's nothing in front, right? If there's nothing in front, what's there always going to be? Like a 1, right? That's a positive 1. So this would be concave up. It's not choice A. Even though the vertex was the same, this graph would actually be pretty much the same one as this, just kind of flipped upside down, so it's like a regular U shape, okay? How about B? No, we already know B's wrong, because, I mean, hey, the vertex, this is going to play on those people that don't remember that they have to switch the sign inside, okay? So since their vertex was a positive 3, they're not going to just put plus 3 inside. You have to put a negative 3 inside, okay? This is going to be one that's going to get those people that have trouble remembering to switch the sign, okay? Now, C is going to be the one that's the best option because it has a negative out front. That tells me it's concave down, and it has that positive 3 inside, and that... Oh, sorry, that should have been a minus 3. My bad. That makes a lot of sense. And a plus 5 on the outside, okay? This is going to be the one that makes the most sense, all right? Now, let's go through one more let's go the opposite way now from my function to a graph, all right? Let's say I give you something like this. And I tell you to sketch this. We've been doing this in our warm-ups, and we've been doing this every now and then, but I haven't really spent a lot of dedicated time to doing it, okay? So, let's talk about what we could do with this. First of all, what do you know about this form? This is called intercept form, right? And how do we find our intercepts? We set each equal to 0, so let's just do that for the fun of it, all right? So we know if I set this equal to 0, I'll get x equals negative 5 and x equals a positive 1, right? Hopefully I don't have to go through the math. All I'm really doing is setting each factor equal to 0, okay? Now what else do we know? We have a negative out front, so what does that tell us? That tells us it's going to be concave down. So we know 2 of the points, and we know what the general shape is. So if I tell you to sketch it, you should have no problem doing that. I'm going to do that off to the side. So I'm going to draw my general x and y axis. Negative 5, somewhere over here. Positive 1, maybe right about there. Concave down. So what shape is that going to be? It's going to be this way, like a U, or is it going to be an upside down U? It's going to be an upside down U, right? That's all I'd have you do, okay? That's all I'd have you do to go from a function to a graph. Now, let's say you didn't know how to do that. What could you always do? I can always just graph this in the calculator just to see. Now, a lot of times when we do this, though, it gets confusing because a lot of us say maybe our window isn't right, maybe we're zoomed too far in, zoomed too far out, and we have a bit of trouble identifying it, okay? Let's do one more this way. Let's say, I don't know, let's do something in standard form for once, all right? Let's do that. 2x squared plus 5x plus 7, all right? And I tell you to sketch this graph, okay? Sketch this. Well, first of all, there's not really a lot of information you can do. You could find the vertex and all this stuff, but an easier way to do it, let's say I just told you to sketch it, nothing else, and here's your answer choices. Here's A, here's B, and here's C. Let's say A was, I don't know, and the y-intercept was up here at 7. Let's say I had this one over here. My y-intercept was down here at negative 7. And lastly, C, my y-intercept's up here, and it's going to be a U shape right there. And it's also going to be at 7. Alright, so when we're looking at this, the problem with this is, again, like I said, it requires you to remember a couple things. Number one, it requires you to remember that whatever your number is out front, if it's positive, it's going to be concave up. If it's negative, it's going to be concave down. So already we know A is off the grid, right? We already know A is off the grid because our number out front, our A value, is a positive. It's got to be B or C because it's going to be concave up. Now, that number out back, what does that positive 7 tell you? It tells you the y-intercept, correct? Right. Now, if it tells you the y-intercept, that means I'm going to have a positive 7 for the y-intercept. This is negative 7. Nope. So our only answer, our best answer choice would be right here on C, okay? I hope that made sense in terms of going from back and forth. Again, like I said, if you're not sure what you can do, by all means, you can just graph it and see what it looks like, okay? You can always graph in the calculator and just look at what it looks like, okay? hopefully this helped. I know it was a lot to go through, and again, like I said, it's going to be delved in different parts. Biggest thing I have suggested for you, and that I would suggest, is just make sure you kind of just know how to convert, make sure you know how to look at your functions, and make sure you just, you know, in general, look over your stuff, okay? Not really going to be too much crazy stuff on the test. Going to try to keep everything kind of basic, simple, and straightforward, okay? Again, let's kind of recap what I suggest you to go look through. Make sure that you are able to go through, you know, all the different forms. Make sure you're able to go from, that was actually number 2 on my list of things to talk about. But number 1 was, you know, obviously factor. Make sure you're able to factor, trinomialism specifically. 2, make sure you're able to go from standard form to vertex, as well as to intercept form. Make sure you're able to do all that, and make sure you're able to identify what the intercepts are, what the, you know, axis of symmetry is, and the vertex, and, you know, with that, make sure you understand the parts of a quadratic and what they mean. Make sure you understand all those words that I just said when I'm talking about the x-intercept, when I'm talking about the vertex, when I'm talking about the axis of symmetry. Make sure you know the definition of them. Make sure you understand what they look like, how to identify it on a graph. Also, make sure you can kind of get your word problems, okay? Make sure you understand how they work. When I talk about max height, that would be, not word problems. Make sure you understand when I talk about max height, that'd be your maximum, which is also your vertex. Make sure you understand, so when something hits the ground, that'll be your x-intercept. And lastly, just a little extra thing, make sure you can at least go from a graph to a function and vice versa, just a little added thing, okay? So make sure you can basically do all of these things, okay? That's pretty much it. I know it's, like I said, it's a lot to go through, but hopefully you've kind of skipped around, looked at everything, and I think that's just about it. Again, last, you know, thing before spring break, I know we voted on tests, so it was kind of you doing it yourself. But anyway, let me know if you have any questions. By all means, I'm good for if you have any questions or concerns, and Mr. Foreman out.